Okay, I'm about to present on something I spent 3 years of my 15 years of NI working on. Anyway, so without further ado, let's go. Come on, you. Did it go? No. Did I not get it? Did I not have it? There it is. Okay, so I'm going to give you a brief history of what the Codegen engine is and how it came to be, and why you would want to use it. After all, you're all CLAs or fairly high-level programmers, or you wouldn't be here in the first place. Then I'm going to tell you how you use it, and with as much time as I have left, I'll give demos. I have the complete tests I used to run when we were running manual tests on this thing, and those have long since been changed into actual real tests that compare code and stuff. But anyway. So, brief history. The Codegen engine, believe it or not, was created in LabVIEW 6.0 for the motion assistant. It was started at the end of 2000. The programmer who started it promptly quit the company, and I was drafted to take it over. So I did, and we released the motion assistant with this. Back then, the vision assistant had kind of broken ground with doing code generation with LabVIEW, but it was not using the Codegen engine at that time. Through the years, things kept getting added to it. More assistants kept using it. So anything with an assistant after its name, like and Signal Express, all use this Codegen engine. And eventually, there were multiple copies of it in VI.live because it wasn't actually a part of LabVIEW. It was a copy of whatever it was using it. So there were multiple versions all over the place. And for LabVIEW 8.0, there was a product called the FPGA Wizard. How many people here know what the FPGA Wizard was? Okay, well, the Codegen engine at that time had been hacked on by about 6 different people with predictable results. It was this huge monolithic thing that was so brittle we would change code calling it rather than change it. But I needed a lot more. But I needed a lot more stuff in the FPGA Wizard. So I completely refactored the thing, and I think that was the last time it was done. There have been, and I refactored it and then added and like quadrupled its capabilities at that point in time. And so there's no way I'm going to get through all of it in this 1 hour. At the end, I will give you, if you just do a Google of LabVIEW Codegen engine, the first hit at the top will be a link to a community page that has a PDF on it with everything you could possibly want to know about the Codegen engine. I'll probably tell you 1 or 2 things that aren't in that, but not much. Okay. In LabVIEW 8.6, we finally got around to doing the right thing and stripping all the excess versions of it out, putting one version in VI.live as part of LabVIEW, and that worked really well until we stripped one out from the Instrument I/O Assistant, and that killed it in Linux. And so we had to port it to Linux. There's no real reason you couldn't port it to Macintosh, but no one's asked. So anyway, so it's a template-based scripting engine. So you create blocks of code, and it stitches them all together and wires them together, cleans up the diagram a little bit for you, and you're off to the races. It's got all sorts of cool things under the hood. It is used in NI underneath the hood for everything that has assistant after it, basically. The Vision Assistant did actually start using it. That's probably why Christoph's here. Okay, so why should you use it? The first reason is it's got over a decade of bug workarounds for LabVIEW. Anyone who's used scripting knows that scripting is not the most stable thing in the world. There are all sorts of weird things that happen, all sorts of corner cases and stuff you have to deal with. The scripting engine ran into all of those things and works around them. So you don't have to worry about it.
What are you talking about? Scripting's perfect. Said nobody knows.
I'm going to stand away as like...
Yeah, I was like, I thought Darren was going to throw something at you.
The other thing is it's been optimized for speed. There is a lot of things you can do in scripting to make things work faster, and I've probably tried most of them and thrown away half of them because they don't work or just weren't worth the effort. The biggest issue with scripting is type props, and the scripting engine kind of gets around that in a few ways. It's also fairly bug-free. It has had no major. When I was dealing with it, when I was here, I didn't have any major bugs on it for years. And in fact, if someone wrote a bug against it, the first thing I would look for is their code. How are you calling it wrong? And that was 90% of the time that was right.
That's what I tell my customers too.
Yeah, but I was right, you know. This thing is very stable. It's been around a long time. The downside, of course, is it's been around a long time. It's not object-oriented. It's using an interface from 2000, which you will see. It has many, many advanced features. You can script into multiple subdiagrams. You can actually script into arbitrary levels of sub-VIs. It will automatically create things like clusters and arrays and growable nodes and stuff, so you don't have to do all that little detail stuff. Where is it? Since it is highly compiled and optimized, it is in platform because it is compiled. So it's in vi.lib platform and something called codegenengine.llb. There are actually 3 top-level VIs there. One is run cgenginedynamically.vi, and that is there purely for backwards compatibility. Use the one that's called run cgenginedynamically 2, or just run cgengine for a direct call. In addition, there are a lot of API functions that allow you to do a lot of advanced features in it, and those are in platform Codegen API. Anyway, okay, so how do you use it? Basic template creation. So if you want to make a template for the Codegen engine, use a normal VI. Do not use a VI template. I can't remember the exact reason why, but I know it doesn't work very well. Yeah. Yeah, I know. And that was a source of great confusion for people starting out with the Codegen engine because we called them templates and they weren't really templates, they were VIs. Anyway, if you want a terminal in a template to connect to a terminal on another template when you're dropping them on the block diagram, those terminals have to be connected in front panel controls and they have to be connected to the connector pane. If you don't connect them to the connector pane, the Codegen engine won't find them. That's how it screens out a lot of extraneous stuff. So if you want to put, say, a graph on your front panel and you don't want to connect it to anything and you don't want the Codegen engine to muck with it, you just don't connect it to the connector pane, and everything will be fine. You want to line up your connections for the best final look. So the Codegen engine, by default, when it drops templates, will try to line up the terminals. But if you have them, 3 or 4 pixels off or something, it's going to do the best it can, but it's still going to be 3 or 4 pixels off, and you'll get jaggy wires and stuff. So what you want to do is try to line them up so everything's the same distance apart. Try to use the same, 444 connector panes and that kind of stuff. There's a lot of optimization. You can customize a lot of that, and I'll get into that later. But for best final look, try to line up your connections. Finally, wrap your entire template in a single frame sequence and name it MXW Framer. So when the Codegen engine opens a template, if it sees a top-level diagram called MXW Framer object, it knows this is my template. This is what I need to do. And that allows LabVIEW to do a move of the diagram of the entire object instead of doing a copy and paste of everything on the diagram. Now, it'll do both, but if you don't have the MXW Framer, it's going to take about twice as long to actually drop the template, and it's going to put things on your clipboard. If you have the MXW Framer, it just does a move from one VI to the other, and it's a lot faster. Okay, so create your templates, drop the Codegen dynamically to or the run Codegen engine on your block diagram. Then you can create inputs from the actual VI, and you populate them. And those inputs will help you to specify templates. When you open a template, you can actually do quite a bit to the template, but the major thing most people do with the templates is they change block diagram constants. Say you've got a frequency generator and you want to change the frequency, you can do that. The inputs to this VI also specify connections between templates, and there are a host of options you can do. And I'm going to cover a bunch of those. And then you run the thing. So once you run it, what happens? all of those inputs are converted into a sequence of commands. Unfortunately, these are not objects. These are LabVIEW 7.1 commands. It then drops all the templates, and when it drops a template, it opens it, it modifies it as you tell it to, and then it drops it in where you told it to. It then, after all the templates are dropped, it then connects the wires that you told it to. The nice thing about that is you can specify connecting a wire to something that hasn't been dropped yet. So when you drop a template and you say, I want to connect to this template, and it hasn't been done yet, it doesn't matter. By the time it gets there, it'll be there. Then it does cleanup. It removes all the excess. So you've got two terminals you've connected together. You don't want those on your final block diagram. It gets rid of all those for you. And it will save it if you desire. That's one of the options when you run the thing. And it does support saving into libraries if you desire. It is also context sensitive, by the way. If you're code-genning into, say, a FPGA context or an RT context, it will properly compile and save to that context. After all, it was refactored for the FPGA wizard, right? So. What? Yes. It was rather interesting when I did it because at the time I was writing it in pre-release LabVIEW 8, and I was code-genning two FPGA contexts. I referred to it as being on the arterially bleeding edge. I literally spent 1/3 of my development time compiling LabVIEW. Because I'd find a bug, they'd fix it, and then I'd have to compile my own.
How much code did you have to rewrite every time they fixed one of your bugs?
Well, that happened too. Steven's not here to tell the tale, but some of those people started running when I showed up. Anyway, okay. So let's get into a little more detail about pre-drop template modification. So you've opened the template, and it needs to be modified a little bit before it can be put down on the block diagram. The reason for this is you can drop two of the same template on a block diagram. The Codegen engine has to know which one's which. And in the modern world, you could use tags to do that kind of stuff, but tags I'm not sure really existed back in 6.0. They may have. I didn't know about them. Anyway, so what happens is everything that you care about that you want to modify or you want to access in this template, you need to uniqueify its name. So it's a very small piece of text that's put after the name. And that's done when you open it before you drop it. Any block diagram constants you want to set, and there's this cool feature that allows you to do conditional code. An example of that would be, say you have a function generator that's going into some block of code. And in some cases you want it to be a sine wave, and in another case you want it to be a sync wave. Well, sync and sine are two different VIs. So instead you drop a case statement, you put the sync on one frame, you put the sine on the other frame, you wire them both out, it's a waveform out, so it doesn't matter. And then when you do the modifications on this code, when you tell the Codegen engine, okay, I want this case statement to be value 0 or value 1, and when you set a value on the case statement, it selects that case and then deletes the case statement. So it's just like as if you selected the case and then deleted the case statement. And so it allows you to put conditional things on your block diagram. That's actually fairly useful because to optimize Codegen engine operations, you want as few templates as you can get away with. And so this allows you to actually do that in a fairly simple.
You do something like that in the AF project provider. There's like 8 possible variations. But
Yeah.
And I didn't write that. Because that was in that maker chart. I wonder if the Codegen code wound up.
It very could have. That Codegen code was in the original Codegen engine that shipped in 2001.
Yeah.
It was originally used to support enums because at the time LabVIEW scripting would not allow you to set the value of an enum. So we use case statements for each enum, and that worked.
Okay.
We won't go into all the workarounds of the old Codegen. Fortunately, most of them, as time progressed, a lot of those were pulled out of the Codegen engine. The Codegen engine actually, the compile process and everything will handle multiple versions of LabVIEW. At one point, it normally supports like everything else, the three previous versions. And at one point, I was shipping with the same version of the Codegen engine 4 different versions, one for each version of LabVIEW. Each had different workarounds due to problems. Fortunately, that's gone. That went away about 2012, I think. Anyway, so now you've got your template modified, and you drop it. Templates can be dropped either at an absolute location or relative to other templates on the block diagram. By default, what happens is you drop the first template, the second template then goes down, and it tries to the right of it, and it attempts to line up the terminals. So it basically takes the positions of the output terminals of the previous template and the input terminals of this one and averages them up, averages the distances and lines them up. So if you want things to really line up well, you need to have the templates be in the same spacing or the same Y range. However, the alignment can be set to almost anything you want to. If you want to specifically say, I want to drop this terminal so that the error terminals line up, you can tell the Codegen engine to do that. It can also align things. You can align things top bottom. You can put things to the left of something. You can align things relative to any of the principal corners of the template of the previous templates. The Codegen engine caches all of this stuff. So if you drop a template and then 5 templates later you want to drop another template below the first one, you can do that. Anyway, another thing is the Codegen engine does automatically wire error wires, so you don't have to do that. And it also automatically connects the error wires to the connector pane. You can suppress that if you want, but by default, that's what happens. Okay, so wiring. Now that we got all your templates down, don't worry, I'm going to show code. Yeah, I just want to get you really in the mood for code. I've got 2 more slides. Okay, so let's do some wiring. Okay, wiring has 3 routing modes. You can do no routing at all, which you would use if you're just dropping railroad tracks and you know there's not going to be any L's or bends in the wires and you just want them connected. You want it fast, so that's no wire routing. You can use LabVIEW's wire routing routine. The problem with that is if you have it all a complex diagram and it has to go around anything, there's a high probability it'll time out and it won't actually give you a route. It will just give you a simple L or a straight line. I was surprised at how often that actually happened. So I created an internal wire routing routine for the Codegen engine, and it is the default. It ended up being faster than the native one, which surprised me. And it also gives you better results usually because even if it times out, and it will time out too, I put a maximum time on it. Even if it times out, it will still give you better than a simple L or a simple straight. It'll basically give you as good as it's got. And because it's the LabVIEW one, I believe, is a high tower, so it just starts going, and if it gets to where it needs to go, it succeeds. The one I did was a depth first algorithm that actually just it drops the wire, sees if it crosses anything, and if it does, it routes around it, sees if that crosses anything, and then routes around that. So it actually ends up being the downside to the one I created is it has no memory bound. It can theoretically eat all of your memory. Now I've never seen that happen in a decade of use, but it could. What?
You have that many structures, then you can't help you.
It also tries to simplify things too. It's not going to do this when it can do this.
We should do a 12-step program for that.
The PDF I referred people to earlier, and I've got a thing at the end, has a complete breakdown of that algorithm if you're interested. Anyway, more advanced features, although this isn't all of them. It does automatic wire routing across diagram interfaces.
There was a question from Mr. Yu. Says, you say it handles arrays and clusters. If you write code to handle some element type, if user then wires an array of that type, will the Codegen engine automatically add the for loop? Another question.
No, it will not. Let's see. Okay, back where I was. Okay, automatic wire routing across diagram interfaces. I'm not sure whether this is still true, but when I was actually writing the wire routing algorithms, if you wanted to use LabVIEW wire routing, you could only do it within a diagram. You couldn't cross a diagram boundary, like say from inside a for loop to outside a for loop. The Codegen engine wire routing algorithm does not have that problem. Let's see, automatic growing of growable nodes. So if you have an output cluster or an input cluster or a decimate array or something and you need to grow it, you can tell the Codegen engine to do that. Now you do have to explicitly tell it. It won't just, connect to here. You have to say, grow this node, add this to it, but it will do it. You don't have to do all the little details of, if anybody's played with that, they know what I'm talking about. It used to be a lot worse. You used to actually have to set the size and not just say add one. Yeah, it's still pretty bad. Okay, the next one is actually kind of cool. There is monitor and abort capabilities in the Codegen engine. So it has a engineer moment. Notifier. Yeah, it has a notifier that you can create, and it will tell you where it is. And
it helps that I'm the current owner of the Codegen engine.
Yes. He said it, not me. Yeah. Anyway, it has a notifier, so it will tell you where it is, and then it also has abort capabilities. There's an abort input, and we'll get into that. So if you abort it, it will stop. It will try to unroll. Unfortunately, the create and end command, whatever it was, I forget. Create something that you're supposed to do at the beginning and end of Codegen didn't really exist when it started, and I never got around to putting it in. So it tries to unroll things, but it may or may not get all the way there. That would be an easy enhancement, but it's just never been done. Let's see. Tagging of templates, terminals, and subdiagrams for later use. One of the things you run into is if you're dropping a bunch of templates, and especially if you've got something like a wizard that may drop a variable number of templates. Let's say you've got something at the end of your drop and something at the beginning that need to connect to each other, and you have a variable number between them. The Codegen engine in raw form connects by raw template number. So if you would have to know what you're going from and what you're going to. But you can tag a template and say, I want to call this template my last template. And that way when you wire to it, you can just say, I want to wire to terminal X on my last template, rather than terminal X on template 6, because it might be template 7 or it might be template 5. Yeah, there's a syntax. There's a little API function that allows you to. It basically overloads the. I'll show it in the code demos. I'll show you how the API works, and then almost every text entry field in the Codegen engine can be overridden and has these little XML tags things that can do other things with it. And those are all documented in that PDF that I will tell you about or told you about earlier. You can set wiring rules on the connector pane. That's easy enough anyway. But and you can also there's a couple of backdoors that allow you to do arbitrary scripting into things if you really want to. Not necessarily something you want to do, but you can. It might be necessary. It's there. Let's see. And there's a lot of other stuff. So, without further ado, I'm going to switch my computer so I'm looking at the same thing I'm showing you guys. This is probably going to. Right. And I'm going to escape from this. Yes.
That's running the bus there.
Okay.
I forgot to put world.
Okay. Let's take a simple. Let's start with a simple template.
So I will point out to everybody, that's the Damien string right here, are part of the LabVIEW auto test suite. So we've got a massive auto test suite for LabVIEW that runs on a nightly basis. And these tests have discovered bugs in LabVIEw, not in the Codegen engine itself, like Damien was talking about, but actually in our compiler that keeps them. And it's the LabVIEW we're working on 2015. in addition to testing all the stuff that Damien wrote, are also very useful to LabVIEW because they're so expansive and they script so many things that we're able to find some bugs in other parts of LabVIEW.
So at this point, it's one of these tests those errors.
That's correct.
Ages ago, when I first wrote these, I actually ran these manually. It takes about a half hour to run through all of these things manually. I think if you do it automatically, it's about 10 minutes. Yeah. Anyway, so this is a template. You notice there are 3 things on the front panel. They're all connected to the connector pane.
Reminder, it's not a VIP.
It is not a VIT. And you can see I have the MXW framer here. I'm going to hit.
So something that hasn't been clear from the slides. What role does the template play in my life?
The template is the code. That's what you're dropping.
The thing that I work. So if I'm writing a wizard, I would have a template that drop this code on a block diagram. So.
Yes.
Okay.
The template is the code you are dropping on the block diagram. It just needs to be a VI.
Do I have to have an MXW framework?
You don't. If you don't use the MXW framer, it'll slow it down because then it has to do a copy and paste instead of a move. Okay.
Gotta have stuff on the content.
It has to be, this frame has to be either a flat sequence or a stack sequence. I would recommend a stack sequence until LabVIEW does away with it. Because stack sequences are smaller and faster, and it's a single frame.
And just naming it, labeling it MX Framer just makes it better.
No, MXW Framer is what the Codegen engine looks for. You have to have it called MXW Framer.
So somewhere, if I understand this right, somewhere in the Codegen engine, it says, oh, I have a template. I'm going to go with this block diagram. It's going to look for a sequence structure called MXW Framer, and then just grabbing everything inside of it is actually like a single scripting call.
Right. It actually doesn't. Yeah. Well, it's actually easier than that. You basically get the reference to MXW Framer, and you do a move. No, you do a move. Move is the fastest thing to do. You don't have to. There's no copy, no paste, no nothing.
And then once you're in where you're going, you can drop the frame.
And then I delete the frame, the other end. And
otherwise, you have to search the block diagram for everything.
actually, no, you don't. You just do select all. You do just select all, copy, and then paste.
That operation takes longer. Okay.
Way faster.
So the sizing and the text alignment of MXW Framer on top of those functions, that's like the only window that gets copied. Is that role for a reason like that?
No, the MXW Framer can be anywhere. I could make this huge and it wouldn't affect the scripting because the Codegen engine knows that you're dropping the code inside it, not the frame.
It's the terminal with the.
Yeah.
So the terminal line is within this really small, not sequences, all that matters. It's not the actual size of this.
Right. So what I've done here is I've got an error. This is actually not going to be deleted because that will be connected eventually. These 2 terminals are going to be connected to something on the other.
So they're just stubs.
They're just stubs, yeah, and they will be deleted before the code is finished.
The alignment of those and the reason they're so shoved into the actual sub-PI is so that it doesn't take up any space.
Right. I'm trying to contract the space of the actual terminal. In fact, the connection point is going to be in the center of the terminal. And it knows it's the center of the terminal. It knows not to use the text.
Your templates are going to be kind of squashed for that reason.
Yeah, they can look squashed. Yeah. Mm-hmm. Okay. Now your first look at a scripting at a VI that actually uses this. Okay. First thing is the Codegen engine does not stop when it hits an error. If it hits an error, it just keeps going because too many times when you're creating a Codegen thing, you can have one little tiny thing that's wrong at the beginning, and it may cause a few other errors, but you'd really like to know what all your errors are and not have to Codegen 20 times to find 20 errors rather than once to find 20 errors. So the Codegen engine keeps going, and if it encounters an error, it drops it on an error stack. And you can see the error stack here on the front panel because I've just wired it up. And the error stack gives you the ID of the command, the data of the command, and then the actual error code associated with the command. And yes, these are internal formats. Let's see, saved VIs. This tells you what VIs were actually saved. When you run Codegen engine on something, you don't have to save the VI. But if you want to, it will, and it will save it in the library if you want it to. And there is also ways to, let's say you have some sub-VIs that you use in your scripting, but they're not in any of your APIs. And you don't want people to save these and then have links to your sub-VIs wherever they are. So there is I think it's a tag called Save Me, and it can be almost anything. It just has to be on the root of the block diagram and have the name Save Me. And if that's in a sub-VI, when the Codegen engine runs through it, it'll save that with the other code, so that and relink it so that it won't mess up your scripting code. I can't remember the details of that, but it's in the PDF. Okay, now let's actually look at the real code here. Okay, first of all, we have the Codegen engine. And let me open that up, and not yet.
I'm very curious as to what are all the widgets I need to...
We're going to get to that. Calm down. We'll get there. Okay. If you want to create a VI, if you want to script into an already created VI, you do it using this VI refnum. You just pass it to VI refnum. You don't have to. If you don't create a new VI, the Codegen engine will create it for you. There are some controls here. These are mostly legacy controls. For example, the first three are things that most people will never ever use. The first one was in the motion assistant. We were showing people the code generation as it occurred, and it was too fast, so they actually put a frame delay so that we could slow it down so that people could watch it code generate. For legacy reasons, that's still there. Anyway, the show diagram is there for the same reason. If you want to show people your diagram as you're code generating it, there it is. I don't recommend it. It slows things down a lot. The Codegen engine also, since it cogens a lot of code, will actually move the block diagram reference along. And the next one, the X location offset, is how many pixels from the left edge of the template you're about to drop is the window going to be moved to. So it moves the window, drops the template, moves the window, drops the template. So you're always seeing the code drop.
So the thought process was like to do tutorials or something like that?
No, this was the motion assistant, and they just wanted to show off the fact that they were doing code generation. Today this seems kind of weird and strange, but at the time it was...
I show block diagrams and project provider. They go really fast.
Yeah.
But I do it as a, sort of an aesthetic choice of like kind of a little spinning thing, but we all see that and we think LabVIEW is in trouble.
Yeah.
Whereas if I just flash a bunch of, front panel tags, you can take them.
Well, in this case, you can use the notifier and let people know where they are and how.
Yeah, there you go.
Yeah. I don't think any shipping product's actually using that notifier. It was used in the FPGA wizard. It worked. It's great, actually. Anyway, so the next three are things that you probably will want to use. The one is you want to save the new VI. And it's kind of yes, no. The default save path is where all the code you're going to be saving is going to go. So that's just the default directory for stuff. And then the clear VI is, and it's by default it is true, if you pass in a VI refnum and clear VI is true, it will wipe everything on the block diagram out before it starts code generating. That was what? Yeah. And then it will start code generating into it. Okay, target file name is just the name of the VI you want to save. It's not the path. The path goes into default save path. Yeah. What? What do you mean the extension? No, it is .vi, whatever. Yeah.
But is that .vi frame in target file name?
Yes, target file name, it's myvi.vi, whatever. Okay, yeah. And then the path it's going into is in default save path. But default save path also is where any libraries or whatever are going to go. Subroutines, that kind of stuff. We'll all go there. Okay. This is the dynamically run version of it, and there is an option to unload at exit that is on by default. Basically what that means is it dynamically loads the Codegen engine, runs your code, and then drops it out of memory, and then closes the reference, which should drop it out of memory. If you don't want to do that and want to keep it in memory for faster use later, you can just leave that on, and it's got a LabVIEW 2 global, so it keeps track of itself. You don't have to do it. Let's see, abort event. That is a simple Boolean event. If it gets generated with a true, the Cogen engine aborts. Drop position parameters. That is one of those bug workarounds. I'm not even sure if the bug exists anymore. But back in the old days, the LabVIEW diagram is 16-bit space. And if you got too far one direction or another and you tried to wire across it, you got insane wires, and when you tried to save, LabVIEW crashed. So the drop position parameters are the workaround for that. So the start X and start Y are the top left place the first template's going to go, unless you specifically tell it to go someplace else. And then it will generate code across the diagram until it hits the max X or max Y. Or if it hits the max X, it will then go back to the start Y, drop, or start X, drop Y ink pixels, and continue doing. Basically, it's a typewriter. And we ran into that pretty quickly with the original DAC wizard. They were like, that was before your time, Chris.
I've blocked those days out.
Yeah, it was. Well, they changed that before release anyway. They had multiple channels, and they were setting each channel operation as a single VI. And somebody tried it with 100 channels, and it just marched off across the edge of the part and just went right off the edge of the block diagram.
Fell off the cliff at some point.
And bad things happened. So we fixed it. Anyway. And down here, there's this alternate CGen engine. So if you want to create your own Cogen engine that calls this exact same thing, that is called exactly the way the one under the hood here is called, you can do that. But it's actually there for internal use, and you'd probably do your own call if you did that. What? Alternate Cogen engine. There are groups inside NI that actually specify their own Cogen engine. Sometimes. They use this one most of the time, but sometimes they specify a different VI to call. Don't ask me why. But
So the alternate Cogen engine will same Cogen recipe?
Yes.
Okay.
Yep.
You're defining the interface.
Yes. Anyway, okay, so VI and refnom, it's just the output, tells you whether it's aborted or not, and I've already explained all of these. Okay. Any question before I go on?
So all of those terminals and controls that you were describing, is there anywhere a Control-H description of them?
I can't remember whether Control-H actually does anything for those, because those things are ancient. Let's see, absolute path. Oops. They're documented very well in the PDF that
Okay.
in the PDF that I've mentioned multiple times. These are all documented very well. Okay, primarily because I didn't want to have to not remember them. In fact, I originally wrote the PDF for myself so I would remember what everything I wrote did. Yes?
So, as far as kind of stages where you could in quarantine, beyond needing to be careful with clear VI, are there any other quarantine Xnodes?
If you're going to use Xnodes, or scripting into Xnodes, or scripting Xnodes is rather interesting because you have to know the exact internal structure of the Xnode. But since it was created for FPGA, yes, it does work.
Okay. Well, I guess as far as scripting goes,
Yeah, and that was one of the reasons it was originally put into vi.lib, is so that the FPGA group could use it to script Xnodes. So yes, you can use it to script inside an Xnode.
I wrote a lot of scripting.
Oh, that's why I'm giving this talk, so somebody else won't do that again. Because I wrote a lot of scripting code too. Anyway, okay, so that's that. Now let's look at an actual use case here. Now this is a simple use case. It's going to drop two templates, it's going to connect two wires between them, and then clean up, and that's it. So to do that, first it's got the, this input is the Cogen recipe one that I mentioned. Actually, I never went over the Cogen recipe. I need to do that before I go further. I got distracted. Okay, this one, despite the fact that it says connections, it's actually the templates. The first element, and there are as many elements in this as there are templates. So the first item in there is, unfortunately, it's a string because this thing was originally called from a C program. So it's got a lot of the inputs on this thing, and this interface dates literally from the 2001 interface. And it is still compatible with the 2001 interface. So anyway, so it's very, very old, and it's and a lot of things are strings that shouldn't be. But anyway, but the first element there is the absolute path of the template. Yes. No, not that I know of. We ported it to Linux in an hour.
I think it would though, like if you had a recipe you made on Windows and you port out some paths and strings, took that recipe, probably backed up because the paths are.
Yes, what I would recommend doing is creating the paths as a path and doing a path string, and that's what I do. That way you do get cross-platform.
Generate the path on each platform and you pass it in.
Yeah, generate the path in the platform as a path, and then use the path string primitive to convert it. Yeah, and then pass it in. Yes. Okay. Next under that is template connections, and this governs what gets connected to what. So the first item is the connector name. So this is the name of the terminal on your template that you want to connect to something else. Underneath that is the connected to name. That is the name on the template you're connecting to, and then the connected to index is the index of the template you are connecting to. So say I want to connect a error wire on template 1 to an error wire on template 0, I would go error out or error in on connector name, and then connected to name is error out, no error, and then template connected to index is 0. The template number is the index in the connections array. That is correct.
So does that need to be specified on both templates?
No, just one. Just one.
So you can leave that blank if it's already specified in the.
Yes. No. The original Codegen engine, that was true, but it doesn't anymore. It doesn't matter. In fact, you can connect terminals of any type to themselves, and as long as it cleans up correctly, you're good. Because basically at the end, it's going to go in and remove all the excess terminals, and if that results in a good wire, you're good. If it results in a bad wire, it will be removed, because that's one of the cleanup steps is bad wires are removed. And that is a common issue with beginning scripters is they'll plop things down and they're not connected. And the reason is they had a bad wire and the wire got removed. Usually you get an error when something like that happens though, because it's usually you miss something or something. But anyway, okay. Parameters. Yes?
Yes, you mentioned we could use tags to connect from template to template. No.
I will get to that. Okay. The tags are explained in the PDF as well. Okay. Okay. Let me quickly get through the rest of this then. Okay. Parameters. These are the things that you change on the template after you've opened it before you dropped it. So you've got a name and a value. Okay. And this is a text string, so it is overloaded with a bunch of stuff. So for example, you can put tags on things. Connector pane, this is how you connect things from your template after you've dropped it to the connector pane of the final. So you've got and this is, as you can see, this is totally separate from the templates themselves. So you've got the template index, and you've got the control name on the template. You've got the terminal location, so that is the actual terminal index on the connector pane. And then you've got the connector pane name. Okay, there is an option. Okay, you've got just standard things. This is the title of the VI, the description of the VI, the icon image path. Despite what it says, it also takes PNGs as well as BMPs. That's an ancient name. I can't. I would break things. And then the help link is literally that. It's a string again, but it is a path to the help file, to to the help for the VI. And then last but not least, you have a name-value pair. These are both strings for options. One of the most common options is setting what your connector pane type is, pattern. And that is the options, there is a bunch of API functions. Actually, I can...
What are those options apply to?
What?
What are those options apply to?
The options down there are global things. So it's things like, for instance, I want to drop my code below the successive templates below each other instead of to the side of each other. Or I want to use the wiring routing algorithm is a good example, because the routing algorithm can be set globally, but it can also be set on a per wire basis if you want to. Yes. And most of those things are also, let's see, should be on my front panel here. Yes. Oh, wait a minute. No, it's not. It's in LabVIEW where it belongs. This piece. Should have opened this earlier. Okay, here's the Codegen API under Platform, as I said, and here's all of the anything that says API in front of it is an API function. There's a bunch of stuff at the end that says XML, API XML. These are subroutines of these things. So, for example, if you wanted to, where's a good one? Okay, password protected. That's a good one. When you drop a template, you can specify passwords so that you can to open templates that are password protected. Or actually, I can't remember whether this one. I think this one refers to the main VI. So if you're scripting into a VI that's password protected, this one will allow you to open the VI. It does not put the password in the cache, and then at the end it closes it and relocks it. So it opens it, scripts into it, and then relocks it and closes it. There is a way also to open locked templates too, although that's less of a use case, because if you're going to drop a template into your code, well, I guess if you're dropping it into locked code, you could do that, and it would make sense. Anyway, I guess I'm out of time.
Yeah, we have like 5 minutes for questions.
Let me just a second. Let me get to the. There is where the.
Yeah, and I pasted the link, and we can paste it on the once we have the video uploaded.
Well, I can. I don't know how much of this code you want me to post onto the website, because I can.
As much as you want.
Okay. What? Run it. Okay.
You've been teasing us for the last 45 minutes.
Run the VI. Here it is. Whack. There it goes. There it is. See, there's the template. See, close, whatever.
So if you wanted to remove the sequence structure, you could, right?
Actually, in this case, you don't want to, because the whole point of the sequence structure is you have to change the plot color after you've actually got something to graph. Yes, this sequence was the second template.
Did you have a single flat sequence around your larger flat sequence?
Yes, I did. Yeah, actually, I can open that for you. Here is the second template. Not much to it.
But now I understand the whole thing about if you made a lot of space to make it look pretty, then you would end up with a really large.
Yes.
Now, but if you're going to be doing the cleanup tool, or you don't do the regular cleanup tool.
I do not do. I always wanted to put the block diagram cleanup as an option, because for simpler VIs it actually does help. But for big ones you would probably not want to. But for littler ones it does help, and but I never got around to it.
You already have a VI reference.
I know. Yeah, it's easy enough to do if you want to. You just take the VI reference and run it.
Any questions? Going on.
I should say that, like, it's cool that the PDF and everything's posted on the community, but call the AEs and ask them to help you, they're not gonna know what the hell you're talking about.
No,
Keep that in mind.
that's why it's supposed to.
Exactly.
That's exactly right.
It's not supported by an
I managed to get permission to post it to community 4 years ago. I think the post is in 2012.
Oh, that's, yeah, we're in the LabVIEW attic, so careful with the rusty nails.
Yeah, this is definitely in the LabVIEW attic.
Attic or the basement somewhere, tool shed.
All right, so,
This is a big power tool with lots of scary